Hi, my name is NURINA BINTI SHAHRIL. My matrix number is CI210106. This is Group 4's Algebra Group Project. Ours entitled Linear Programming in Real Life Application Domain. And below are my group members' names and matrix number. So the first part is part A, which is the linear programming in real life application domains. The first application is the Sinaro or Sedem Berhad company. The second application is the supply chain management. The third one is the manufacturing production planning. And the last one is the linear programming in agriculture.
Right. Hi, doctor. My name is ROSHAN. My matrix number is DI 2043. So, for my part, I'm going to present about the first real life application problems, which is for Sinaro or and Berhad. So, with this, that I have checked is Mr. Arun Kumar, who is the CEO of Sinaro or company, capable to make three kinds of them with types of profits, which are 1,000, 15,000, 17,000, and 20,000. Each kind must respect following conditions. So the first will be for supply reasons, the number of buildings of kind to build each month must not exceed the number of kinds by more than two. So the second one is for staff reasons, Mr. Arun Kumar can make each month up to 3, 3 and 5 respectively of kinds 1, 2, 3. So for the third one is for organization purpose, Mr. Arun Kumar can make up to 8 buildings monthly of kinds 1, 2, and 3, respectively, in the proportion of 3 to 1. So Mr. Arun Kumar, having these data, wants to maximize his monthly by knowing the number of buildings of each kind to build monthly. So this will be the table. So for scenario organization Indian Bharat, the building. So we have profit 1, profit 2, and profit 3. So X, Y, Z, and also number of buildings. So profit 1 for X is 0, Y is 1, Z is negative 1. The number of buildings are 2. Profit 2, X is 3, Y is 3, Z is 5, and the number of buildings is 15. Profit 3, X is 3, Y is 2, and Z is 1. Number of buildings are 8. So this will be the formulation of linear programming problems. So first is the coefficients of economic functions. We have 15x plus 17y plus 20z equals to 0, which is the first equations. So next will be subjects to constraint. Y minus z equals to 2. That's the second equation that we have. 3x plus 3y plus 15z equals to 15. That is the third equation that we have. And the fourth one will be 3x plus 2y plus z equals to 8. That is the fourth equation.
Hello, I am SUJJASHRI from SUBRAMANIAM and my metric number is CI230148. So my real life applications real situation is supply chain management. Linear programming is known as widely used in supply chain management, which is SCM, to improve the allocations of resources among the suppliers and distribution centers and retailers. The applications of a linear programming approach can successfully address cost-related issues. According to the study by Dr. Yusuf and Nana in Connect in 2014, the study found that using linear programming in SCM can lead to significant cost saving by identifying the most efficiently allocated of resources. Additionally, the approach allows for better coordinations and collaborations among different entities in the supplier chain, lead to improved overall performance and customer satisfactions. The supplier chain optimized problems under considerations are expressed as linear programming problems. In corporations, transportation costs that arise in various practical applications. Okay, this is the analyst survey data for my real life application. So this one is solving the transportations problems with linear programming models. we use double suspicions decision variables fit. Okay, let's say I'm giving you one example which is x12, the number of truckload transport from plant 1, ABA plant to depot 1 maybe. So uh, here have some of the transport problems with here. Okay, this one is the general transport program minimizations model is, okay, this is the objective functions. So this is the main part for this. So minimize z is the first equations, and the second equations is like construct on total available truckload at the each plant, and the third equations which is constructs on total truckloads are needed at the depot. So this is the main objective functions for my first my second real applications. Okay, this is the third part for my application, real life application, which is sensitivities analysis rules. So have two. First is for the objective functions, coefficiency, and then another one is for RH as construction. Okay, this is the one for my final part, which is formula of transportations problem has a linear programming model. Okay, the objective functions can be represented as, okay, minimize z. So here have some calculations, which is 0.2808 x 11 plus 0.4176 x 12 plus 0.20 4x13 plus 0.5544x14 plus 0.6912x15. So like here we have a fourth equations, and from this we should calculate our from the truck loads from every each transportations problems in the linear programming models. And for this, for conclusion for my part is, okay, the study analyze transportations costs in a company using data from a table. The truckloads from EBA plants to Maybas Daytop X11 shows zero movement, while those to Chalabar Depot X14 are 1008 truckloads, and to UO depots X15s are 144 truckloads monthly. So here various factors such as maintenance, fuel, drivers well-being, and loading or offloading causes significantly impact transportation's expenses. So here the study suggests either to limitations to minimize this cost, and then it should be maintenance is identified as the most suspicious expenses, accounting for 39.20% of the company's total transportations expand over 6 years. So these explorers the influence of sensitivities analysis on the optimal solutions of the linear programming problems, emphasizing the impact of modifying individual data elements of the solutions. It recommended minimization truck maintenance costs through predictive and preventive methods, or to optimize transportation's expenses challenging, and conventions practices for the cost reductions. So only this from me. Thank you.
Well, I'm Yoaghini Dr. Letchmanan, and my registration number is CI20154. Well, for my part, I'm going to continue with the third linear programming in real life application domain, which is titled on manufacturing production planning. So, as we know, linear programming can be used in various fields to improve or enhance their performances. But based on this article that we have chosen, so according to Solarja 2019, linear programming has been used as a great and effective tool in manufacturing production planning. So, based on the article given, management can make a better decision or can make an ethical decision by identifying the manufacturing process and also improve their profit by using the linear programming techniques. So, as a production manager, they should make a better decision or a rational choices by distributing the limited resources that we have in order to maximize their use on manufacturing or production by producing uh, a product or services that they are focusing on. But as per the financial stability and sustainability of an organization, they can be compromised by an inadequate of allocation of resources, which can lead to an operation failure as well. So, as a production manager, they should make sure that they can optimize the distribution of limited resources they have, which is like labor or materials and equipments, to achieve their goal on optimal efficiency by using the linear programming technique, which is known as a good or powerful tool. So, to be more in details, firms can increase their productivity and also reduce their cost by make a better decision by allocating the limited resources, which would ultimately improve their overall financial performances and also production. In addition, linear programming can help to discover the possible inefficiencies or obstacles that could be faced by any organization in the future during the production process, which would help to manage to solve the issues and also assure efficient operations by empowering them into making an accurate choices or better decision using the technique that they follow based on the linear programming. Moving on, as per the diagram shown here, we can clearly see that the objective of the study conducted was to maximize the profit, where the CI represent the profit that derived from the sales of the products, and also XI represent for the number of bags that produced for each of the products that given. And below there, we can see the model that can be written in this canonical form based on the study that conducted. And J was referred to the layer mesh, grower mesh, broiler starter mesh, and broiler finisher mesh, following with I, which is means for a kilogram of materials that we used, and BI for the resources that available. As per the diagram that given, we can conclude that this study focuses on mainly addressing production planning challenges in a feed mill company through the uses of a linear programming technique. And the main objective on conducting this study or analysis is to optimize the allocation of resources that they have, such as raw materials and machinery, in order to maximize the production output and also to minimize the cost that they cost during the production. And the data for the study was obtained from the company's record was with input from the production manager to clarify some certain aspects. The linear programming model that suggests prioritizing the production of layer mesh as shown here, leading to the maximum of 80 percentage in increasement in the profit. So the study is emphasizes on the importance of making an analytical or ethical decision making, which recommend the use of linear programming over using some heuristics model or other techniques for an efficient resources allocation and also to increase the profitability. So, additionally, the research also suggests that implementing cost saving strategies and optimizing the production process to enhance their overall operational efficiency and to make better decision making, which would be guided by using analytical or scientific methodologies by a manager or a firm to acquire their skills in using or applying linear programming techniques to achieve their main goals.
Hi, my name is NURINA BINTI SHAHRIL. My matrix number is CI210106. For the next part, I'll be talking about the fourth application, which is the agriculture area, a crucial sector for global sustenance. Okay, by implementing linear programming in resource allocation in agriculture, it can bring substantial benefits. Countries like Saudi Arabia support agriculture projects through irrigation to boost crop production, leading to notable economic growth according to a journal in 2020 by AJG and Akin Sumande. So by maximizing profits in agriculture, it requires considering factors such as crop yield, weather conditions, market scale, government policies, pest control, and soil fertility. Efficient farm management involves allocating crops to small cultivation spaces, leading to higher productivity and profits compared to crops planted individually or in groups by other farmers. Here we have the linear programming model that determines the matrix A, vector B, and vector C, values with known dimensions using the simplex algorithm. From here, we can see that the Z is the net revenues from all crops, the C are the profit from unit area allocated to each crop, the X values are the areas to be allocated to each crop, the A is the technological metrics, B is the constraints. Okay, here we have the given linear programming model aims to maximize the objective function Z, which represents the total value or benefits derived from the production of various crops, such as XS, XM, XR, XW, and so on, each multiplied by its respective coefficients. So the model is subject to several constraints, each representing limitation or resource availability in the agriculture system. Here are the explanation of some of the constraints. First constraint is the land constraints. This constraint limits the total sum of crop variables on the land to be less than or equals to, in this case, 8.48. And then the second part is the human labor constraint. This constraint represents the availability of human labor for different crops. And then the third constraint is the animal labor constraints for different crops. The third constraint is the tractor hours. This constraint specifies the availability of tractor hours for different crops. And then there's the fifth constraint, which is the urea availability in this case. And then the sixth constraint is the DAP availability, which is a constraint involving the diammonium phosphate fertilizer for different crops. And then there's the seventh constraint, which is the nitrophos availability, which represents the nitrophos fertilizer for different crops. And then there's the FYM availability, which is the eighth constraint. And then the ninth constraint, which is the number of irrigation available for different crops. And then that's all here. So here is another constraint, which is the cost constraint. This constraint represents the cost limitation in the production system. And then below is the lower bound constraint. These constraints set lower bounds for the decision variable X. So the above quoted results reveals the grower's optimal set of crops, including the areas. The simplex algorithm solves linear programming problems, calculating objective values and generating shadow prices for constraints. A field survey accessed 355 growers in Peshawar, focusing on crops, yields, revenues, costs, and inputs, with constraints set for crop drops. These constraints aim to maximize growers' objectives, suggesting policy changes for sustained improvements. The linear programming formulation enhances resource allocation, cost savings, and crop yields, contributing to economic growth, environmental sustainability, and food security. Implementing the suggested solution gradually is recommended for substantial development.
So now I'll be presenting about part B, which is the manual calculation. So now we are going to present about the manual calculation, as I mentioned before. So the problem that we choose was the first real life application, which is for Sinaro, Rigres, and Berhad. So the problem in the conical form can be written as below. So z equals to 15x plus 17y plus 20z, y minus z equals to 2. Then we have the equation of 3x plus 3y plus 15, 5z, sorry, equals to 15. 3x plus 2y plus z is equals to 8. So now we need to make all variables non-negative. Okay. So therefore, replace all the unrestricted variables xi with x plus and below is I minus w. So this will be the equation that we get below. So since we don't have a basic basis, so we have to add artificial variables. So such as like as below, which mentioned that z equals to 15x plus 17y plus 20z plus minus 52w. So y the next equation will be y plus y power of plus minus z power of plus y1 equals to 2. So we just continue below like that. So the first phase is to solve the following problem, which is below. So for this for the entire equation, we have to put into a table form so that we can solve it. So so this is the table, this on top is the table. So first is we have to add two rows multiplied by m to row, so which is equals to row 1 equals to r1 plus m r2. So after we plus the m, and then we have to go for the next step, which is add row 3 multiplied by m to row 1. So which is equals to row 1 plus equals to row 1 plus m r to the power of 3. So after we have done that, the next step will be add row 4 multiplied by m to row 1. So which is basically r1 equals to r1 plus m to r times 4. Okay, after we have done that, so now the entering is the variable x positive, because it has the most positive coefficient 6m in the z row. So the first z row we have the most 6m. So the leaving variable is y3 because it has the smallest ratio. So after we done that, the next step will be divide row 3 by 3. So R3, so we are doing it for row number 3. So it is okay, R3 over 3. After we have done that, the next step will be subtract row 4 multiplied by 6m for row 1. Okay, so we are doing it for row 1. So R1, R row 1 minus 6m R4. Okay, so after we have done that, so now we have to go to the next step, which is subtract row 4 multiplied by row 3 by 3 from row 3. So R3 equals to R3 row 3 minus 3 R4. Okay, after we have done that, we know that the entering variable is x positive because it has the most positive coefficient in 3m in the z row. So we have more positive answers in the z row. Okay, so the leaving variable will be y2 because it has the smallest ratio. So now we have to divide row 2 by 4. So R2 equals to row 2 divided by 4. So the entire row 2 we have to divide by 4. So after we have done that, we have to subtract row 3 multiplied by 3m from row 1. So row 1 equals to row 1 minus 3m for the row 3 times row 3. Okay, so after we have done that, so we add row 3 to row 2. So R2 equals to R2 plus R3. Next will be we subtract row 3 multiplied by 1 over 3 from row 4. So row 4 equals to, so R4 equals to R4 minus R3 over 3. Okay, so then we have seen the entering variable is y plus now. So because it has the most positive coefficient 5m over 4 in the z row. Okay, so the leaving variable is y1 because it has the smallest ratio. So now we have to multiply row 1 by 4 over 5. So R1 equals to 4 R1 over 5. So next will be subtract row 2 multiplied by 5m over 4 from row 1. So row 1 equals to R1 minus 5m over 4 R2. So now we have to subtract row 2 multiplied by 1 over 4 from row 3. So R3 equals to row 3 minus R2 over 4. Next will be subtract row 2 multiplied by 7 over 12 from row 4. So R4 equals to R4 minus 7 row 2 over 12. So none of the z row coefficients are positive. So we have finished the first phase. So now the second phase is to remove the artificial variables and solve the following problem. So z equals to 15x plus power of plus 17y to the power of plus 20z to the power of plus minus 52w. So y plus minus w is 3, x plus x positive plus minus w is 1 over 2, and also the next will be x plus z to the power of plus minus w is 1, x plus power of plus minus w is equals to 1 over 3. So now we have to write down the simple table, So next will be our motive now is to make the z row consistent with the rest of the table. So I have to add row 2 multiplied by 17 to the row 1. So R1 equals to R1 plus 17 R2. So next will be we have to add row 3 multiplied by 20 to row 1. So R1 equals to R1 plus 20 times R3. So this will be the last table. So add row 4 multiplied by 15 to row 1. So R1 equals to R1 plus 15 row 4. So now none of the z row coefficients are negative. So we have already reached the optimum. So the last one will be the following solutions is obtained: z to the power of plus, y to the power of plus, z x to the power of plus, and w, which is 1 over 3, 3, 1, and 0. Okay, so z will equals to be 76 is achieved at x, y, and z. Therefore, building monthly 1 over 3, 3, and 1 buildings of kinds 1, 2, 3, Mr. Arun Kumar can make a monthly profit of RM 76,000. So next, now I'll be presenting about the coding that we have done over C program. Okay, doctor, so now I'll be explaining about the coding. So the first line will be hash include studio, which includes the standard input output library for input output functions. Okay, so the second line will be includes the mathematical library for mathematical functions. So define C max 10, which is for basically defines a constant C max with a value of 10, representing the maximum number of variables in the economic function. Okay, so next will be define V max 10, defines a constant V max with the value 10, representing the maximum number of constraints. Okay, so next I'll go for the integer NC, NV, no optimal, P1, P2, XERR. So that declares integer variables. So next, the next line will be double TS C max, V max. That is for declares 2D array TS with dimension C max by V max to store coefficients and constants. Sorry. Okay. So double TS is for declares 2D array. So the constant, yeah, correct. So next will be void data. That is the beginnings of definition of the function data. Next will be the double R1, R2 declares two double precision variables. The next line, chart 3 declares a character variable R. Okay, integer I and J declares integer. So printf, which is print the messages. And also we have printf maximum Y or N, which is basically to ask the user whether to maximize or minimize and stores the response in the variable R. So printf number of variables of economic functions, which is basically scanf d all, basically ask the user for the number of variables in the economic functions and store the response in NV. Okay, so next will be printf number of constraints, and then okay. So now we go to the important part. If R equals to Y and so on, this line is to if the user chooses maximize, R1 is set to 1.0. Otherwise, it is set to negative 1.0. Okay. So next we'll printf the input coefficient of economic functions. So this print a message of prompting the user to input coefficient for the economic functions. So next will be for j equals to 1, j NV and then J++. This starts a loop for inputting coefficients where J iterates from 1 to NV. Okay, so next line will calculates the assign the coefficient to appropriate position in TS arrays. So the line 20, which is ends the loop, then we'll print F right hand side function. This asks the user for the right hand side value and calculates or assigns the appropriate position in TS arrays. So the last line will be it starts a loop for constraints whether I iterates from 1 to NC. So now I'll be explaining about the next part of the coding. So just print F constraint. So this prints a message indicating the current constraint being processed. So for the next one will be it starts a loop for inputting coefficients for the current constraint where J iterates from 1 to NB. Okay. So next we print F, ask the user for coefficients and stores it in R2. Okay, so the fourth line of the coding will be TS bracket I plus 1 bracket J plus 1 equals to R minus R2. This is basically stores the negative of the coefficient in the appropriate position in TS array for the current constraint. So next will be right hand side, we printf right hand side. So we ask the user for the right hand side value and stores in the appropriate position. So next is we printf the results. Okay, so next will be void pivot declares the function of void formula declares the function of formula, optimize declares the function of optimize, void simplex begins the definition of simplex function. Okay, so next will be E10. E10 is a pivot, labels a point in the code as E10 and calls it pivot function. Okay, so next will be formula, calls the formula function. Optimize, we call the optimize function. And then if so the last one, if noptimal equals to 1, go to E10. So if the solution is not optional, okay, noptimal is 1, jumps back to the label point E10 and repeats the process. Okay, so next will be for J equals to 1, all that, initialize the first row of TS in the variable indices. Okay, so next will be for I equals to NV plus 1, that row. So this row initialize the first column of the TS array with select and surplus variable indices. So for the next part of the coding, okay, so the wrap 9999.9.0, which initialize the wrap to a larger value. Okay, so which will be used to find the minimum ratio. Okay, for I equals to that line, it starts a loop iterating over constraints in the TS array starting from the second row, index 2. Okay, so next if TS equal TS I and all go to TSI, okay, copy to go to E10. Okay, so correct. So if the coefficient in the pivot column P2 is non-negative, it jumps to the label E10. Next will be VFABs TSI, sorry. It calculates the absolute value of the ratio of the right hand to the coefficient in the pivot column and assigns to B. So next will be if V more than wrap, okay, if V is smaller than the current minimum ratio, updates wrap and sets P1 to the current row. E10, label E10 marks the end of the loop, finding the minimum ratio. Okay, continuing with V equals to TS 0. Okay, so that will swaps the indices of the basic variable P1 and the entering variable P2 in the top row of the array. Okay, so continuing, for I1 starts a loop iterating over rows in the TS array. If I equals to P1, if the current row is pivot row, jumps the label to E70. So I'll talk about the looping now. Okay, so the loop here is TSP1. You can see that below the E70. Okay, calculates and store the reciprocal and the pivot element. For j equals to 1, starts a loop iterating over columns in the TS array. If j equals to P2, go to E100. Okay, E100. So if the current column is the pivot column P2, jumps to the label E100. Next is TS P1 bracket j. It updates the element in the pivot row using the absolute value of the reciprocal of the pivot element. So E100 labels the E mark the end of the updating the pivot row. Okay, doctor. So now I'll be explaining the next part of the coding, which is the last part. Okay, sorry, it's long. So label E110 marks the end of loop for updating the pivot column. Okay, so the next function will be void optimize. It begins the definition of the optimize function. Okay. So next will be integer ij, declares integer variables I and j. Okay, the next line will be check if there's a negative value in the right hand side column of the array for non-basic variables. If found, sets SYAHIRAH to the 1 and optimal to 0. Okay. So the next line, if SYAHIRAH, okay, it return if there is an error, it returns from the function. So numbers lines of the line after that is basically check if there are coefficients in the objective function row that are greater than 0. If found, sets optimal to 0. Okay, so now I'll continuing with the functions. Okay, so void results. Okay, so void results begins the definitions of the result function. Integer ij declares the integer variables I and j. Okay, so if SYAHIRAH equals to 0, go to E30. Okay, so if there is no error, it jumps to the label E30. Okay, next will be printf no solution, and the E30 for bracket I equals to 1 and almost that line is the nested loop to iterate over variables and constraints, checking if the current variable is a basic variable and printing its value if it's true. Okay, so the next line will be printf economic function. Printf prints the value of the economic function. So E100 printf label E100 marks the end of the function and prints a new line. Okay, so the main function of this coding is void main bracket data bracket simplex bracket results brackets. This defines the main function which calls data to gather the input. Okay, simplex to perform simplex algorithm and results to display the results. Okay, this code, so come to the end. So this code implements a simplex algorithm for linear programming, handling optimization problems and displaying the results. The various labels, example as E30, E70, E110, are used for control flow within the program. Thank you, doctor. That's all from me.
Now for the output. So here is the output of coding. We have run an example here. So first part is the maximize y/n. The user input y. It indicates that the user wants to maximize the objective function. And then the second part is the number of variables of economic function, where the user input 3. It means that there are 3 decision variables in the economic function. The third part is the number of constraints, where the user input 3 means that there are 3 constraints in the problem. Afterwards is the input coefficients of economic functions. And here the first coefficient x1 is 15, the second coefficient is 17, the third coefficient is 20. Means that the economic function is 15x1 plus 17x2 plus 20x3. And then afterwards is the right hand side for economic function, which the user equals 0. It means that the constant term in the economic function is 0. Okay, and then we move on to the constraints. So the first constraint, the coefficient of x1 is 0, the second one is 1, the third one is -1, and then the right hand side for constraint is 2. And then the constraints for #2, for the variables in constraint 2, the first coefficient is 3, the second coefficient is 3, the third coefficient is 5, and the right hand side for constraint variable #2 is 15. And then for the constraint at #3, where the coefficients for the decision variables, for the coefficient 1 is 3, coefficient 2 is 2, coefficient 3 is 1, where the right hand side for constraint 3 is 8. So, and then we have the results, where the optimal values for the decision variables for the x1 is approximately 0.333333, and then x2 is 3, and then the x3 is 1. The optimal value of the economic function is 76. That is all from us. Thank you for watching.